Last day we found how to find the actual slope of the tangent using the slope formula that we had learned before, but also the idea of a limit. So as a warm-up, we're just going to remind ourselves of how we actually find the slope of a tangent. So in this one, we're going to find the slope of a tangent of the function y equals negative 2x squared, and we're going to find it at x equals 1. So we're finding our slope, and remember, our new formula then is the limit as h approaches 0 of f at a plus h minus f at a all over h. In this particular example, I'm asked to find the limit, or the slope of the tangent, excuse me, at 1. So it's going to be 1 plus h minus f at 1 all over h. So the idea is we're going to take this 1 plus h and sub it into the function. So the function is negative 2x squared, so it's negative 2 bracket 1 plus h squared. And we'll plug in our actual point at 1. So negative 2 times 1 squared all over h. We'll do some simplifying. And again, remember, be careful when you square 1 plus h. That's 1 plus h plus h plus h squared. So 1 plus 2h plus h squared. You probably get used to doing a bunch of those, so you won't need to write it out every time, but it's still worth being careful. So 1 plus 2h plus h squared. In the second half, we're actually doing the number, so it's 1 squared, which is 1, times negative 2 is negative 2. All divided by h. If I'm going too fast, I apologize. This is a review from yesterday. If you need to pause the video or rewind it, then you're welcome to do that. Keep simplifying. I'm now going to multiply this by 2. So it's negative 2 minus 4h minus 2h squared. And this is going to be a minus minus 2, so that becomes a plus all over 2. Good news that it's a plus because we know that the constants should all cancel, and there's a negative 2 plus a 2, so that's going to cancel. And that will allow me to divide by h. I couldn't do that before because not everything had an h in it, but now all that's left has h's in it. So I can divide everything by h. That becomes a 1. This becomes a 1. And h squared divided by h just becomes h. And so that's going to leave me with the limit as h approaches 0 of negative 4 minus 2h. Now I can actually take the limit, evaluate the limit. I couldn't do it at any of the steps here or here because I was always dividing by h. And I can't sub in h equals 0 in those cases. But now that I've been able to cancel the h's out, I can actually take the limit, which means I say I'm actually at 0. And I get a slope of negative 4. So when you see the whole picture here, you can see that what I've done is I found the slope of the tangent at x equals 1 in this function. Gone off, used our formula, found out that the slope of the tangent at x equals 1 is negative 4. I can actually go to Desmos and confirm that the slope of the tangent of this function at x equals 1 is indeed negative 4. So here's my function, negative 2x squared, and I've got all the different tangents I want to go over here. So I'm at x equals 1, or a equals 1, and indeed there it is, the IROC, or the instantaneous rate of change, the slope of the tangent is indeed negative 4. So in that example, I had a function and I found the slope at a specific spot. But if I was really interested in all sorts of tangents, I could go off and ask you to find the slope at x equals 2, x equals 3, x equals negative 1. If we had Desmos, it's easy. We just drag this and we drag it to a new position and figure out, oh, x equals 2, slope is negative 8. 3, -1 or -2, let's see, -2, 8. But if I didn't have Desmos and I needed to redo this question but at a different x, I'd have to start over. So I'd have to start over and start over with x equals 2, do this whole thing here with a 2 plus h, rainbow, collect all the terms, go off and find the slope. And then do it again at 3, and then again at -1, blah, lots of work. So I'd like to find a shortcut. So instead, what I'm going to do is I'm going to, instead of find a slope at a specific spot, I'm going to let that spot be a variable and let it be x. So instead of subbing it in there, instead of using a number, I'm actually going to just leave it as a variable and trying to get a formula that describes all of the slopes. And of course, the formula or equation that describes all of the slopes is the derivative. So let's redo this question, but instead of using an actual number, we're going to use x. So we're still finding, we're still going to use the same formula. F at a plus h minus f at a all over h. We're still taking the limit. But instead of a number plus h, we're going to let that remain a variable and just call it x. So we're going to take x plus h and substitute it into the function. So the function's still -2. Instead of x squared, it's x plus h squared minus, and then if we just plug in x, it's obviously just -x squared all over h. We're still going to simplify as if it was a number, but instead of 1 plus h, it's going to be x plus h squared. So I'm going to do rainbow again off to the side here just to make sure I'm careful. X times x is x squared. X times h is xh. There's another h times x, so xh, and finally an h squared. So that's x squared plus 2xh plus h squared. So this x plus h squared rainbows out to -2 x squared plus 2xh plus h squared, and then the other part is minus minus, so it's going to be a plus 2x squared. All over h. So again, if I'm going too fast, don't be afraid to ask the supply teacher to pause. But I've just rainbowed x plus h squared, and now I'm going to do the rainbow I did before, but now I'm going to rainbow in the -2. -2x squared minus 4xh minus 2h squared plus 2x all over h. So the math looks very similar to what we had done when we were actually using an x equals 1, but now when we're using an x, it's still, the math is pretty similar. At this stage, this is where our constants disappeared. Well, since we never used a constant or a number, the numbers aren't going to disappear, but something is. You'll notice that I have a minus 2x squared and a plus 2x. Well, just like in the one before, the -2 changed and the +2 changed. These are still going to cancel. And anything that doesn't have an h in it should disappear. Remember, like I said before, I need those things to disappear so I can divide by h. If they didn't disappear, I wouldn't be able to divide this by h, or this by h, or anything else. But because they do disappear, I do only have terms left with h, and I'm going to do the same cancellation I did before. Divide everything by h, there's a 1, there's a 1, x squared divided by h is just h, and I'll be left with negative 4x minus 2h. Looks very similar to what we had before. Now, because I was able to divide by h is gone, and I can actually evaluate the limit. I can take the limit at h equals 0. So I can sub in h equals 0 now. So it's negative 4x minus 2 bracket 0, and that's going to be just left with negative 4x. And then what negative 4x is the equation that describes all the slopes of tangents. And that thing is called the derivative. And so now instead of finding just the slope, I've actually found the derivative of that original function. So if I wanted to find different slopes, if I wanted to find the slope at 2 or 3 or negative 1, I don't need to restart and do this whole thing. I've got an equation that describes the derivative, and so I can use it to find any slope I want. So if this is the derivative, let's check x equals 1, because we already know that answer. So the function is, it's negative 4x. So the slope would just be negative 4 times 1, which is negative 4. And that matches the derivative we found before. But if I wanted the new derivative, say, or a new slope, say x equals 2, all I need to do is sub in the 2 in for x, and I get that the slope is negative 8. Or if x equals negative 1, it's negative 4 times negative 1, and the slope is 4. So this equation, this derivative, allows me to find the slope of any function, or any tangent I want within that function. And all I had to do was all this long work once to get the equation. But once I have this equation, that's the derivative. I can even verify it on Desmos. I can go over here, negative 2. Look, the slope is 8. Oh, sorry, I did positive 2, didn't I? Positive 2, the derivative is negative 8, or the slope is negative 8. There it is, right there. X equals negative 1, the slope should be 4. Let's confirm it on Desmos. X equals negative 1, and the derivative is 4. Any derivative can be found now that I have any slope can be found now that I've found the derivative.